this one cannot. So I will be snipping this one in and showing you how to work through it. I remember last time we started doing these at the end, and I'm sure focus kind of goes away after 2 hours. So just try to give your best here so that you can do some of this on your own when you have to on the test or quiz. Okay, so let me share my screen and we'll get started.
Oh, and I got a 90 on the test that I retook.
Fantastic. Do you know what your new grade is at?
Yeah, so I went from I think it was a 66 to a 72.
Okay, so one more grade like that, and probably up to maybe even a B. So
yep.
Fantastic.
Close to it at least.
Yeah.
Right.
I'm sure mom's happy.
Oh, she's very happy.
Great. Okay, so cosecant of theta is, we always draw a triangle in the first quadrant like this, something like this. And cosecant is the same as 1 over sine theta. So if cosecant theta equals 19 over 18, then you can similarly say 1 over sine theta equals 19 over 18 because they're equivalent. On the left here, you flip. So you change it to be sine theta, and then you flip the right. So you flip the left, flip the right, and this helps you now because sine is opposite. This is opposite over hypotenuse. Okay, and then to find the missing side, you have to use the Pythagorean theorem. A squared plus 18 squared equals 19 squared.
Right.
So if you've got a calculator, I'm gonna have to grab one here for the 18 squareds. So it's a squared plus 324. 19 squared is 361. So when you subtract here, so you subtract 324, subtract 324, so a squared equals 37. So a equals the square root of 37. Okay, so that's this side. Okay, so if you've got, I don't know why it's not copying. Okay, so if once you get the 3 sides of the triangle, to find the other 5, it's fairly straightforward. So again, like what you're going to do here is you're going to write out the 5 trigonometric functions: sine, cosine, tangent, or 6 actually, and then there's cosecant theta, secant theta, and then cotangent theta. So you were already given cosecant theta. It was 19 over 18. Sine is the flip of that. We already figured that out. Cosine theta is the adjacent over the hypotenuse. Do you see how I got that? A is adjacent to this.
Yes.
Okay, so we have words like adjacent that I'll be using the entire lesson: adjacent, opposite, and then hypotenuse. The secant is the flip of this, which is 19 over the square root of 37. Now, when we were doing this last time, the answer would just accept that. You may have to do what's called rationalize, which is where you multiply the top and bottom by the root. So this becomes 19 square root 37 over 37. Tangent theta is opposite over adjacent, so it's 18 over the square root of 37. Okay. Cotangent, you flip it, so it's the square root of 37 over 18. But again, like the tangent might not look like this. You may have to rationalize by multiplying the top and bottom by the square root of the bottom. So it becomes 18 root 37 over 37. So there's some mapping here to what you're looking for, and you may just have to scan through the answers to find it. So whenever you're ready, if you want to go ahead and share your screen again, we can look at the next question, or I can even help you scan through that one to figure out what the right selection is.
Okay.
Sorry, I know this isn't as easy as the last one. So the first thing is you're looking for where it's sine of theta is 18/19. So that gets you down to the first two, it looks like. And then you want to maybe find one more that's matching. So cotangent theta is the square root of 37/18. So it looks like it's letter A.
Okay.
And maybe doing a couple more here will help to make this. That one's not okay. So let's.
Got stuff all over. I said, did you find room?
Yeah.
So let me snip this in. But before I share my screen, the reciprocal of secant is cosine. So cosine is going to be the flip of those two numbers. So can you see that it gets down to, and cosine's the COS. Can you see that it's down to letter A or it's down to letter C to start? Scroll up just a little bit to the back to the question. See how if you go back to the question, it says secant, SEC, secant theta equals 34/33. The reciprocal of secant is cosine. So cosine is going to be the flip of those numbers. It's going to be 33/34, and cosine is COS. So do you see how in letter A and letter C, cosine is 33/34? We're still not. I'm going to snip these in, and I'm going to try to explain what I mean here. Okay. Let me share my screen and see if I can give you a little clarity on this. So what I'm trying to say is this right here is given, and secant theta is 34/33, and secant is the same as 1/cosine. So if you flip the left, like if you switch positions on the left, you have to also switch positions on the right. So cosine theta equals 33/34. Let me know when you're there to.
Okay.
Are you everything okay? Keep going.
Yeah.
Right.
Yeah.
So what I was trying to like make clear is that like you start with this, but you immediately can figure this out down here because secant and cosine are reciprocals of each other. Okay, and why does that help? Well, cosine 33/4 is right there, and cosine 33/4 is right there. So that means that one is out. And same thing with the last one. Are you following that?
Somewhat, yeah.
Okay, I mean we're just literally matching, 3 letters and 2 numbers, 3 letters and 2 numbers.
Right.
And now we got to decide between these two. All right, so to do that, you really want to draw the triangle here. And so the triangle that you always draw is the one that's in the first quadrant here. It's okay if you don't know what I mean by that, but draw the same one every time. So cosine is adjacent over hypotenuse. So the adjacent is 33 over the hypotenuse, which is 34. And then to find the missing side, you take the square root of the hypotenuse squared minus the leg squared. And this is just a Pythagorean theorem situation. So let me just grab this number here for you.
And then which sides are A, B, and C for on the triangle usually?
You get to pick, but A and B are usually always the legs, and C is the hypotenuse.
Okay.
And sometimes A is the smaller leg compared to the other one. So anyway, we've got the 3 sides. Okay. Now, since you have to do this over and over again, like you've got to look for ones that are different. Do you see how cotangent is different in both of these?
Yeah.
And same with tangent. The tangent here is different than the tangent here. And same with the sine and the sine and the cosecant and the cosecant. What that tells you is you only have to find one of the other ones to be able to do it correctly. So let's, for example, find the sine of theta. I'm sorry, this is 67, not 37. So let's find the sine of theta. The sine of theta is the opposite, the square root of 67 over the hypotenuse, which is 34. So you're looking at, you're comparing this one to this one down here, which is the match.
The one up top, the first one.
Yes. Okay. Okay, so when we do the next problem, I'm going to try to help you figure out which answers you can remove and then only find the missing sides that you need to be able to answer this question more quickly and give you a better shot of being able to figure it out on your own.
Okay.
All right. So if you could just scroll down slightly to get all the answers in there. That's good. There we go. Perfect. Okay. Let me grab one more snip. Okay. So let me share my screen. I'll try to, this is the time where I think if we can maybe make some associations to help like figure this out. So if you're seeing my screen, let me make sure you see my screen there. It says that tangent is 5/2. So tangent of theta is 5/2, and 1/tangent is really cotangent of theta. Okay. So if you flip this to this, you get cotangent of theta, and that means you have to flip this as well. Okay, so it's like you really want to do the following. You really want to go 1/tangent theta equals 1/5/2. And instead of writing tangent of theta, you write cotangent of theta. Instead of writing 5/2, you flip it to 2/5. So notice on the left here, cotangent, 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 and cotangent, they're all 2/5. So that didn't help very much. Didn't help very much. But in the previous problems it did. So that's what you're looking for. Like you need to know there's reciprocal properties. You need to know all of them. So now let's draw our triangle here. Tangent is opposite over adjacent. So it's 5/2. Okay, and like you were asking before, this is A, this is B, and this is C. A squared plus B squared equals C squared. 2 squared plus 5 squared equals C squared. And then when you solve this, you get the square root of 29. Okay. And unfortunately, it doesn't look like we're not going to like quickly find anything to eliminate, but we'll do it one at a time. So let's first find us a cosine of theta. Cosine of theta is the adjacent over the hypotenuse. So when you go back up to your picture, adjacent to this angle right here is 2, and the hypotenuse is the square root of 29. It's 2 over the square root of 29. And you do have to rationalize, which means you have to multiply the top and the bottom by the square root of 29. All right. So now we just go look for the one. We look at the cosine in each one. So the C. Oh, you know what? I'm sorry. Let me back up here. I wasn't looking very carefully. The cotangent is 2/5. This first one says cosine. That's out. The second one says cosine at the top. That's out. These two were okay. See how it's COT, COT. So we actually did get a break there. Now cosine, let's look for cosine in each of these. There's cosine in the third option. There's cosine in the fourth option. Which of those matches this one here?
The bottom one.
Yes.
The
I'm sure seeing all these numbers and letters is very overwhelming, and it's a lot to sort of like digest and figure out how to do. But it looks like we're going to always be able to get rid of 2 answers right away.
Yeah.
Okay. So whenever you're ready, go ahead and share your screen again, and we'll again try to figure out how to go through the next question in a simple way.
Okay.
Well, actually, we switched questions. So could you just scroll down and see if there's any more that are like the first grouping that we did?
Yeah. I'm gonna say most likely not.
Yeah, sometimes they're encoded though into other questions. Well, good news is this gets
Right.
faster.
It isn't that big of a test.
All right, let's go to 11. Let's start with 11. We need to do some easy. Yeah, let's do.
Okay.
I'm sorry, go up
Sounds
one more.
good.
10. Go to 10. Sorry, let me go up one more. There we go. Perfect. Let me grab 10, and actually I can grab 10 and 11. Just let me snip them both in. Then I'll share my screen. Yeah, like sometimes I'm thinking, well, why aren't we starting with some easier stuff to kind of build up to what you want to work on? But that is not the case. Okay, so let me share my screen. So first thing is we want to have an understanding of where is 153 degrees on the unit circle. So for some reason, and I don't know the answer to this, but angle of 0 degrees is right here to the right. And so if you rotate in this direction, this is considered 90 degrees. And if you keep going, this is considered 180 degrees. And it's counterclockwise.
Right.
I don't have any clocks anymore that have, those hands, but I do remember, what clockwise is to the right, counterclockwise is to the left. And that's just the convention that they use. So 153 degrees, if I get rid of these, you would agree it's somewhere over here on the left. Like you start here and you go somewhere like that. And that's 153 degrees. Okay. Here's what coterminal means. Coterminal means the following: you either add 360 or you subtract 360.
Okay.
So 153 plus 360 equals some number. 153 minus 360 equals some number. And I'm guessing one of these will be on the answer sheet here. Okay. So do you have a calculator handy?
I have my phone.
Sure, you go for it. Let's get those out. Desmos has a what is it called? It's a scientific calculator phone app. It's pretty handy if you're
Cool. Would it be 513?
513 degrees, yes. And then the other one is negative 207 degrees, I think. And you can see that that one is correct there for that.
Okay. So you basically just add or subtract whichever coterminal
Yes.
the degree is in, pretty much. Okay. Oh,
For-
that's really easy.
Right. And for now, that's very straightforward.
It's very straightforward.
So we'll see if that continues here. So you add 360 and then you subtract 360. Okay. And again, this is no guarantee that it's going to work, but it should work, and we'll see here. So let me know. No, I've got 11 up. I've got the next one up.
Oh, you already got it up.
Yeah.
Okay.
Okay, so this actually, I'm glad this is the next problem because it illustrates the exception to what I just said.
Mhm.
So do you see either of these numbers on the left?
No.
So what you have to do now is you have to again add 360 and subtract 360. So you essentially keep doing it until you find your answer.
Okay.
So it's
That's
not
that bad.
it's not horrible, but it's not as easy as just like, yeah, you know, here's, so this is minus 608, and I think it's going to be the one above it. So this one is 832. So in pictures, and I think this will be much more helpful, 112 degrees is right here.
Mhm.
So when you add 360, you're just going around and getting back to the same place. And then you go down or go around again and get back to the same place because there's 360 degrees in a circle.
Right. Okay, sorry, I'm just writing this stuff down. So it'd be 832.
It looks like it, yeah.
Okay. And I got 12 and 13 up for you.
All right, why don't you try number 12 on your own there, Jayla?
Okay. Let me guess, it'd be plus or minus 180?
360.
360.
Yeah,
Okay.
yeah. Make sure you get that down on a note sheet because that's key.
Oh, okay. No, I get that now. Cool. Negative 546.
That is correct, yeah.
Yeah.
Okay, so let's go to 13. Is there a couple below that, or is it just 13? It's the only convert to radians problem.
13 and 14. We have one with pi.
Great. Scroll up.
Two
Yeah,
pi.
let me grab 13 and then I'll have you scroll down. Okay. And then I'll ask you to scroll down to grab 14. Okay. And could you just scroll down slightly so I can grab the next one? Perfect. All right. Okay, so let me share my screen and we'll get started on this new problem. So the conversion from degrees to radians, like most things, there's a formula, there's a recipe here. And it's when you're going this direction, because you could actually go the other direction, you multiply by pi divided by 180. So you take your angle that you're given, 35, and you multiply by pi over 180. Okay. Now I'm going to send you a link to this Desmos Scientific because this is a skill that I think will really benefit you on a test or quiz. Let me see if I can find it real quick. Yeah, there it is. Okay, so let me send this to you in the chat, and then I'm going to show you how to do it. I'm going to show you how to do this problem with. Actually, I want to have you share your screen because it'll be easier for me to talk you through it. Could you open up that link I sent you, and we're going to enter this into the calculator, but we're going to maybe do it a special way to see how to use it.
Okay.
So this is different. It's not the graphing tool. It's an go to the one on the left.
Oh,
There
here
too.
it is.
Yes, there it is. So type in 35 divided by 180. Okay, and then do you see how there's a fraction button there on the right in the circle? Click on that. Okay, excellent. Now go back to your answers. And is there one that is 7/36?
No. Oh, wait.
We're looking at 13. Is there one that's 7/30? Yes, but it's got a pi next to it. Do you see that? And that's okay. The answer has, but could you go back to the Desmos Scientific? Okay, so go back to the left there where it says 35/80 and just click in that area and then hit the pi button. It's down right there. Perfect. Now see how it converts it to a decimal? You don't want that. Okay. You want to leave it. You want to leave the pi out when you're doing calculations. Because when you put pi in, it'll give you the decimal always, and you don't want that. You know there's a pi with your answer. Okay, so go back to your quiz. Okay, scroll down to 14. So the 14 is going backwards. So this one, I'm going to share my screen, and then I'll show you what to enter into the Desmos Scientific. So when you're going the other direction, and this is really the key thing to take down in the notes, is when you're going from radians to degrees, okay, when you're going the other way, you multiply by 180 divided by pi.
Okay.
So this means you take minus pi over 30 and you multiply by 180 over pi. And if obviously if you're comfortable, you could do this by hand, but you could also go to that Desmos Scientific and enter this straight across, and you will get the right answer. So do you want to give that a try there on that calculator? You can either share your screen or just enter it on your own. It's got to look exactly like this though.
You want me to share my screen, you said?
It's up to you if you want to try that, or I can talk you through the numbers to enter, but it's
just talk me through it.
Sure.
It'll be easy. All right. Well, it was negative pi, right?
Yeah, I'm not seeing your screen quite yet.
Oh.
Yeah, so it's negative pi divided by 30. Okay, and then you go to the right there and you multiply, and you need another fraction. So that's 180 divided by pi. There it is. Yes. So if you know what to enter, you can use this tool to figure out the correct answer. That is correct on that one.
Okay.
Okay, so what I see is we got through kind of the second half here. I know we got to go back to like question.
Pretty much just, I think it's just these.
Yeah, let's go start with 4. And I'll kind of, if you want to just frame that there, I'll grab it and we can talk about how to do it.
Okay.
This one has a lot of numbers, not quite as many as the first one, but it's still got a lot going on. So it can feel like, where do I start? What do I do first? This is a right triangle. One of the angles is 19, one is 90. We've got to figure out the third angle. Okay, so the way this works is when it's a right triangle, these other two angles have to equal 90. So if you subtract 19 from both sides, E equals 71. So that means this last one is out. Is that okay? Is that clear?
Yes.
Okay. Now to find the other ones, we're going to use sine, cosine, or tangent. So sine is opposite over hypotenuse. Tangent, I'm sorry, cosine, let's do these right over. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. And unfortunately, they don't give you, they just give you the one side there. So we're going to use tangent. And I'll explain why in a moment. But the tangent of 19 degrees, here's 19 up here. It's the opposite over the adjacent.
Okay.
Okay. Now we want to solve. We want to solve for d. D is 12 tangent 19. So you can go to that Desmos Scientific, and you can enter this expression here, but you have to make sure you're in the mode of degrees. You'll see there's a toggle for it. Will you give that a try, please?
Yes. Uh, 1.81.
Is your mode in degrees?
Yeah. It is supposed to be 4.13.
Yes. Yes.
Okay.
And so you'll see
Then I
that and you'll see that is letter A. That's the right D value. And since it's different from all the rest, you don't have to continue solving the triangle.
Okay. I'm going to take a picture of this really quickly. Okay.
So whenever you're ready, if you want to share your screen, we'll look at the next set of questions. So if you want to frame that question 5, I'll snip it in. And we're going to use the same approach. The first thing we're going to do is find that third angle. So I'll share my screen. Okay, so the third angle here, down here on the right, is 35 plus E has to equal 90. So you subtract 35 from both sides. So E equals 55 degrees. So that gets rid of this one. It's either B, C, or D. Is that okay?
Yes.
Okay. Now we really want to find E, because you can see how they're all different for E. All three of these are different.
Yeah.
So which one do we use? Well, there's two options here. We can do tangent of 35, and tangent is always the opposite over the adjacent. So relative to 35, opposite is 27, and the adjacent is E. Okay. Or we can do the tangent of the angle on the other side. And I'm doing this so you can see which one is easier. Tangent of 55, the opposite is now E, and the adjacent is 27. So notice on the left, you have the variable on the bottom. On the right, the variable is on the top. So the one on the right is preferred.
Okay.
Okay. And the reason is because you can multiply both sides by 27 to clear the 27, and E equals 27 tangent of 55. So again, make sure your calculator mode is in degrees, and go ahead and enter that and see which one matches the answer that you're looking for.
Would it be 38.55?
Looks good to me.
Or 50?
So which answer does that correspond to? Looks like it's the second one there.
Yes. Okay.
All right, so question 6 is very similar. Let me grab it here. So all the stuff you're doing here is considered it's shown in geometry, and then they cover it in trigonometry. It's not really part of Algebra 2, but some Algebra 2 courses overlap into these courses. So let's first find that missing angle E. 39 plus E, the other angle there, has to equal 90. Subtract 39 from both sides. So E is 51 degrees, and that gets rid of that answer right there. Now, I know in the previous problems we've been using, well, actually, let me look here. Do you see how the answer for E is different in each one, but not in D? So we want to get E. And we have been using tangent, but tangent relies on opposite and adjacent. We want something with a hypotenuse in this. So sine, cosine, and tangent, we're either going to use a sine or a cosine. So for example, the cosine of 39 degrees is the adjacent. The adjacent is E this time, the co, and then the hypotenuse is 22.
Okay.
So now to clear the 22, you multiply both sides by 22.
Mm. 17.09.
Very good. So it looks like it's that first option there. If this were a free response, we would have to go and find the other side, but since the multiple choice, you only had to find one of the missing sides, it looks like.
Okay. Alright. These should honestly be easy for the next ones. They look easy at least.
They're not bad. Once
I have the pie chart thing too, or like the unit circle. I have that whole thing.
Yeah, well, I mean, it's only useful if you really want to take more math. I mean, it won't offend you. You don't. So, all right, let me share my screen. I'll try to again to explain how to do this in a way that's hopefully understandable. So, on your unit circle, there are 4 positions: 0, 90, 180, 270, and then if you get all the way back around, 360. So each 90 degrees, you go 90, this is a circle, even though it may not look like it, 180, 270, and then 360. So they're saying, like, where's 260? Well, it's got to be between 90 and 180, right? And it's closer to 270 than it is 180. So it looks like this. So you're looking for something that looks like that in pictures. So,
okay. Yeah, so it's going to be B.
Yeah, most likely. Can you give me the next angle that they ask for in the next problem?
700 degrees.
How much?
700.
700, yeah. So this one's different.
Yeah, I've already found it.
So if you go all the way around the unit circle, if you go all the way around, that's 360.
Right.
Okay. Now they generally don't show it that way. They show it as a spiral. So they'll say, oh, I went all the way around and leave a little bit there. So that's 360. And then if you go all the way around again, that's 360 plus 360, which is 720. But this is less than that. So you have to back it off a tiny bit. So what I mean by that is you're not going all the way around, you're going almost all the way around. So it's like you will go all the way around and then there's something there like that, a little bit less.
So like you could add like 360 plus 270, right?
360 plus 340 gets you to 700. And
Okay.
and so that's really the one that you're looking for, is like, where's 340? And 340, we can actually, you know, is 0, 90, 180, 270, 360. We know it's over here. So it's something like that. But you go all the way around again to get there.
All right. To the next question. The next one is negative 340.
Negative 340. Yeah. So what's challenging about this one is negative means you're going in the opposite direction. So normally it's 0, 90, 180, 270, 360. But when you're going negative, and I'll do that in red here, when you're doing red, you start here. This is negative 90. This is negative 180. This is negative 270. And this is negative 360. So you're going the other direction. So it's like you're going around this way there, because it's got to be past 270.
Okay, yeah, I got that one then.
Fantastic.
Oh, and that was actually the last one.
All right.
And I got a 14 out of 14.
Fantastic.
Yay. Fantastic.
We've got 5 minutes left if you would like to use it, 5-6 minutes. It's totally up to you. If you got some other stuff, you can share your screen and we can look at.
Okay, let me see. I know I have some big ideas, but I don't know how many I have because I haven't really been keeping up with it, but it shouldn't be too many.
Sure.
Yeah. Wait. I've just been working on my newest assignment for a little bit.
All right, so this one's a good one to do in your Desmos there. So go ahead and split your screens like we did the other day. Put the assignment on the left and the Desmos scientific this time on the right. Yes, very good. So you have to, grab, and you need to go just a little bit further down on the, if you want to grab that top middle and just drag to the middle of the right. Okay, you can do that too. If you want it to snap, just drag it further down into the right middle. Okay, that's good enough. So you take 12 radians. Okay, so type the number 12. And when you're going from radians to degrees, you multiply by 180 divided by pi. Okay, and see how it wants your answer in degrees to the nearest tenth. That's why you know you can go to the calculator for the 687.5, it looks like.
Yeah.
Okay. So this time we're going the other direction. So you take 40 and you multiply by pi over 180. Yeah. The problem is going to be, and you're going to see this in a moment here. Go ahead and type that. You see how you get a decimal answer there? That's no good. It doesn't want that. So you need to remove your pi from your calculation and just put maybe a 1 there. Okay. And then convert it to a fraction. So your answer is 2 over 9, but then you have to put a pi next to it. So if we can get these rules straight, you'll see how to use this tool to do that. Maybe it's under advanced. Yes, there's no advanced. That's really interesting.
It is.
So sometimes you just type pi to get pi. Nope.
No.
Something like that. This is yeah, so there it is. There it is. Right, that should do it.
Yeah.
Okay, so this one is 315 times pi over 180, but because it wants an exact answer, you leave it as 7 over 4 times pi. So if you put the pi in there, it's gonna give you a decimal, and you don't want to do that because it doesn't say to round.
Okay. And then 260.
Yep, you can put negative 260 in if you want. It won't matter. It's either going to be positive or negative. You know, it's going to be minus 13 or 9 or 13 or 9. No, you want to go back to the fraction on the right there. Oh, you did. Okay, I'm sorry. You and then you got to put the pi in.
Oh, I'm like,
So there's extra steps because we're trying to like not really do it the most math way, we'll say. We're just trying to use the tool to help speed it up.
Right.
So this is minus 25 over 9 times pi.
Okay, probably 1 or 2 more.
This time you multiply by 180 over pi. So type your pi over 9 in that first position. Yeah, and 180 over pi there.
$20.
All right, this will be our last one here. Same thing here. 3 pi over 4.
Around 35.
Yeah. All right, so you can probably do a bunch more of these with the calculator, you know, if you want to between now and then. But thanks so much for letting me help you. We will be stopping here. I'll send you the notes in the screen recording here shortly, and I'll see you next time.
All right, awesome. Thank you very much.
You're welcome. Have a great day. Bye now.